Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture Lecture Series on Sunday, June 8th at the JFK Auditorium, St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, St. Augustine.
On the 4th of July 1989, I became the first parallel supercomputer scientist to record the world's fastest calculations. As the first parallel supercomputer scientist, I was mandated to solve the grand challenge problem of physics and mathematics, and to solve it by parallel processing the grand challenge problem as 65,536 initial boundary value problems of extreme scale computational fluid dynamics. My grand challenge was to figure out how to chop up that real world problem of extreme scale algebra and chop it up into 64 binary thousand smaller initial boundary value problems, and most importantly, figure out how to subsequently parallel process those computational physics problems, and how to do so across my 2 raised to power 16 processors that were tightly coupled to each other and that shared nothing between each other. In the 1970s and 80s, I walked along a technological trail that was orthogonal to the trail that was walked by the vector processing supercomputer scientist. I walked alone. I walked through the darkness that was the unknown world of the massively parallel supercomputer that was the precursor to the modern computer. Metaphorically speaking, I walked within the unknown territory of the massively parallel supercomputer, and I walked with only a small lamp to see by. That lamp was the most massively parallel ensemble of processors ever built. The reason I was left alone to discover how to make an ensemble of 1 million processors solve 1 million problems at once was that it was then said that parallel processing is a huge waste of everybody's time. I walked through darkness and into the light and did so with equations. How are modern supercomputers used? 9 in 10 parallel processing cycles were consumed by extreme-scaled computational physicists. Their grand challenges include executing computational fluid dynamics codes that had the Navier-Stokes equations at their calculus core, or executing the petroleum reservoir simulator used to discover and recover otherwise elusive crude oil and natural gas, and the general circulation model used to foresee otherwise unforeseeable global warming. At the granite cause of most real-world problems arising in computational physics is the system of coupled nonlinear, time-dependent, and 3-dimensional partial differential equations of calculus that contains partial derivative terms that represented something in the physical problem the equations governed. Parallel processed supercomputing is the Formula One of science and technology. The fastest supercomputer in the world is 10 million times faster than your computer. The fastest supercomputer is powered by 10,649,600 cores that were totaled across 40,960 nodes. The supercomputer of 1946 was rated at 5,000 cycles per second that could be executed during an arithmetical operation on a 10-digit number. Today, the parallel supercomputer that can record a speed of 1 exaflops could be manufactured. The flop is the acronym for floating point arithmetical operations per second. Exascale supercomputing is achieved by massively parallel processing at the speed of 1 billion floating point arithmetical operations per second. That speed of supercomputing is equivalent to a quintillion or 10 raised to power 18 calculations per second. The fastest supercomputer speeds make it possible to create extreme scale and high fidelity computational fluid dynamics simulations. Like any technology, the parallel supercomputer is a double-edged sword that can be used to do both good and bad things. The supercomputer is a vital instrument that is used to execute computational fluid dynamics codes that model blood flowing through the human cardiovascular system. The supercomputer that can be used for computational medicine and used to understand how to increase human longevity can also be used to design weapons of doom. The parallel supercomputer is used to design bombs that are more than 3,000 times more powerful than the atomic bomb that was dropped upon the Japanese city of Hiroshima. On August 6, 1945, that atomic bomb killed 166,000 Japanese. Because supercomputers are used to simulate nuclear explosions over cities like New York, the US is reluctant to sell American-made supercomputers to quote-unquote unfriendly nations. This security threat is the reason the US Department of Commerce vehemently objects whenever Japan sells a supercomputer to a nation that is unfriendly to the United States. This was the origin of the infamous supercomputer denial list that had been in existence since the 1950s, when it was against the law to export an American supercomputer to the Soviet Union. This, in part, is the reason that in the 1980s, I was the only Nigerian that was supercomputing within US nuclear research laboratories.
Insightful and brilliant lecture.